Hello everyone and good morning or afternoon. My name is Konstantinos Gofas, and I will be showing you how to operate the Dionex 2000. This is an ionic chromatography instrument that measures the amount of inorganic anions that are in wastewater. It is used in this lab to test for the presence of fluorides, chlorides, nitrites, sulfates, and nitrates. First, as you can see, there are 3 blanks before the standards are measured. The first 2 are to essentially clean the column of any residue from past runs, and the last blank is to zero or tear the system as you would with a balance. Next, being that this is an environmental laboratory, there are regulations from the EPA and a standard operating procedure that must be followed. There must be a calibration ran of known values to show that the analyst is doing a proper job and that the instrument is not faulty. In this case, there are 6 standards, all of which go from lowest to highest concentration of the analytes. After that is the standard 4 validation, which does a check and is then compared to the laboratory control sample. After that is the RL, which is the reporting limit and is the same as standard 1, and lastly there is a blank to clear the column of any residue and to do another check. Finally, we can get into our samples, and these are our unknowns. With wastewater, typically they are ran initially with a 1 to 10 dilution factor due to high chlorides present, and the values must fall within the calibration curve. Some samples I have had to do a 1 to 1000 dilution solely due to the large concentration of anions. Now the SOP calls for a matrix spike and a matrix spike duplicate to ensure the quality and validity of the results. Lastly, there is a run for DI water to clear the column, a final check of validation of standard 4, and another run of DI water. In this picture I have set up and labeled the polyvials where the samples will go in and be analyzed. To start the instrument, first I have to prime the pump. To do so, I will click Pump Settings and then click Prime. I will make sure that the check valve on the pump is open before continuing. Typically I will pull out around 10 milliliters and then turn off the pump. Before I remove the syringe, I close the valve to prevent any air from going into the system. Next I click Start Up and it will turn on the temperature stabilizer, pump, eluent generator and the suppressor. I have to let the instrument run for around 20 minutes to clear it out and to let it stabilize. While the instrument is warming up, I will prepare the samples by taking 5 milliliters of sample after it has settled, because the sediment can clog up the instrument, and put it in a 50 milliliter volumetric flask and label it. It is now time to pour the samples into the polyvials. This part is the most time consuming, so enjoy the show on 8 times speed and the jams. I am now making the matrix spike. In 2 polyvials labeled matrix spike and its duplicate, 5 milliliters of sample is put in using a 5 milliliter class A pipette. First I condition the pipette with the sample. Next I use a 50 microliter syringe to put 25 microliters of known analyte into each polyvial. I will more than likely be keeping those samples in the refrigerator just in case the analytes are out of range, and it will be an easy dilution should I need to. Next is the fun part, each vial gets its own little filter plunger. I also get to push them down and they make a satisfying noise. To me at least. Now that it has been more than 20 minutes, I double check everything because it is better to run it once than twice, which I have unfortunately had to do once, and now the instrument is ready to run. To start the analysis on the instrument, I click Batch, Start again. This screen is telling me approximately how much eluent it will need. Click OK. Now I go to the auto sampler and click the Hold/Run button. And now the instrument has been started and it is in the process of analysis. This is a screenshot of standard for being analyzed. The first peak is fluoride, which makes sense since it is the smallest out of all 5 analytes. Next is chloride, which, from my experience, is typically the largest peak in the unknown samples. After is nitrite, and then sulfate, and lastly, it is nitrate. This isn't the best picture, which I do apologize for, but it is fairly understandable still. The graph you see is a similar graph to the previous picture. As you can see, there is the amount in milligrams of analyte per liter of sample. And those values you see right below are the values that would be reported to the client. Those values are calculated from the software program, which takes into account the peak height and the retention time as well as some other constants. Honestly, this is a fairly easy test to run, and also interpreting the data is very easy as well. The setup is tedious, but I have been doing this test for about 6 months and I can set everything up within 30 minutes and then interpret it in about 5 minutes. With this information, it can be applicable to similar and newer instruments that serve the same function. Thank you for your time and hope you learned something.